This is a video from section 12.5. The directions say to find the equation of a plane. Let's take a look at problem 31. We want the equation of the plane through the points 0, 1, 1, 1, 0, 1, and 1, 1, 0. So to find the equation of a plane, we need a point that lies in the plane, and we need a vector that is normal to the plane. Well, we have 3 points that lie in the plane, but what we're missing is the vector that is normal to the plane. So what I'm going to do is let P equal the point 0, 1, 1. Let Q equal the point 1, 0, 1, and let R equal the point 1, 1, 0. Now, let's take a look at a picture. So notice how we have a plane, and we have 3 points that lie in the plane. Now, with these 3 points, we can form vectors. So I'm going to form the vector PQ, which is equal to 1, negative 1, 0. I'm going to form the vector PR, which is equal to 0, 1, negative 1. If we take the cross product of PQ and PR, we're going to get a vector N that runs perpendicular to both PQ and PR, right? So in other words, N is the cross product of PQ and PR up here. Now, N turns out to be the vector 1, 1, 1. And at the end of this video, I can show you how I arrived at the vector 1, 1, 1. Now, since both PQ and PR lie in the plane, N is orthogonal to the plane. Okay? And so we can take N as the normal vector. So now N is the vector 1, 1, 1. And we have 3 points to choose from, so I choose P equal to 0, 1, 1. Now, what's the equation of a plane? In general, the equation of a plane is A times x minus x naught plus B times y minus y naught plus C times z minus z naught equals 0. Okay? Now, A is 1, B is 1, and C is 1. Okay? So A, B, and C come from the normal vector N. X naught is 0, y naught is 1, and z naught is also 1. And so all I have to do is plug in that information. So 1 times x minus 0 plus 1 times y minus 1 plus 1 times z minus 1 equals 0. And so therefore x plus y plus z minus 2 equals 0. And that would be the equation of the plane. Now, what you can do is double check yourself. So if we choose a different point than P, so what if I chose Q? Now, Q is the point 1, 0, 1. We should come up with the exact same equation of a plane. It might look different in the beginning when I plug it into the formula, right? When I plug it into the formula, it'll look a little bit different, but when we simplify it, I claim we're going to get the exact same equation. So, in other words, I'm going to take 1 times x minus 1 plus 1 times y minus 0 plus 1 times z minus 1 and set it equal to 0. And when I simplify, you might notice that I'll get x plus y plus z minus 2 equals 0. And I got the exact same equation. And I claim if I use R, it will also work as well. And that's how we do problem number 31. I want to show you problem number 35. 35 is really good. We want the equation of the plane that passes through (3, 5, -1) and contains the line x equals 4 minus t, y equals 2t minus 1, and z equals -3t. This is an incredible question, right? Because I claim it's no different than problem number 31. And I want to draw a picture for you. So we have a plane. And I'm going to let P equal the point 3, 5, -1. So we'll put P here. And here is the line. And so what I want to do is pick 2 points on the line, right? Because if the plane contains the line, it contains points on the line. Okay. So in other words, I'm going to let t equal 0. I can pick any 2 points I want. If I let t equal 0, we'll call this point Q. So Q will equal the point 4, -1, 0. So we'll put Q here. So this is the point Q, and I'm going to form the vector PQ, by the way. And so I'm going to let t equal 1. It's just real convenient, and I'll call this point R. So R will be the point 3, 1, -3. And I'll put R over here. And I'm going to form the vector PR, incidentally. Okay? Now, PQ is equal to, so 4 minus 3 is 1. -1 minus 5 is -6. And then 0 minus a -1 is 1. PR is the vector. 3 minus 3 is 0. If I take 1 minus 5, I get -4. And then -3 minus a -1 is -2. Just like this. Now, n, so we'll put n up here, by the way. Notice how n is a vector that runs perpendicular to both PQ and PR. So again, we're going to call this vector n. Now, this is the vector. First component is going to be 16, right? -6 times -2 is +12, minus a -4, so 16. The second component is going to be the opposite of -2, which is 2. The third component is going to be negative 4. So let's review what we've just done, right? We have a point P that lies in the plane. And I have a line L. Okay? If the plane contains the line, it contains 2 points on the line. So in other words, the plane must contain the points Q and R. And so what we've done is reduce this to the following. So instead of finding the equation of a plane through a point that contains a line, we are now finding the equation of a plane through 3 points. That's exactly what's going on here. Okay? Now, this is what we have. So we have n, which is equal to the vector 16, 2, negative 4. Right? And the point P, well, that point is 3, 5, negative 1. Okay. Now, A times x minus x naught plus B times y minus y naught plus C times z minus z naught equals 0. That's the equation of a plane in general. Okay? A is 16. So I'm going to take 16 times x minus 3 plus 2 times y minus 5. Okay. C is negative 4. So minus 4 times z minus negative 1. And I'm going to set this equal to 0. So 16x minus 48 plus 2y minus 10 minus 4z minus 4 equals 0. And I require that we simplify, right? And so what am I going to do first? Every term has a factor of 2. So I'm going to divide everything by 2 to make this look a little bit easier. And when I do that, I get 8x minus 24 plus y minus 5 minus 2z minus 2 equals 0. Okay? And then from here, I get 8x plus y minus 2z, right? And then negative 24 minus 5 is negative 29. Negative 29 minus 2 is minus 31. So I get minus 31 equals 0. And we can double check ourselves, kind of like in the last problem here. So remember that n is the vector 16, 2, negative 4, right? And we can choose Q. Let's go back. Q is the point 4, negative 1, 0. And we could check, right? We should come up with the same equation. So if we take 16 times x minus 4 plus 2 times y minus negative 1 minus 4 times z minus 0 and set this equal to 0. So if we do that and simplify, we should come up with this equation. Now, look at what we have. 16x minus 64 plus 2y plus 2 minus 4z equals 0. divide through by 2. So 8x minus 32 plus y plus 1 minus 2z equals 0. And it looks the same to me, right? So if we go to simplify this, we get 8x plus y minus 2z minus 31 equals 0. Because notice, negative 32 plus 1 is minus 31. And we checked a second point and got exactly the same equation when we simplified it. So that's how we do problem number 35. Now, if we had a question on getting the normal vector, right? Let's go through that. Remember in problem 31. So let's go back to problem 31. And let's remind ourselves, PQ is the vector. We're going to get 1, negative 1, 0. PR is the vector. And we're going to get 1, 0, negative 1. And we want N. Remember, N is the cross product of both PQ and PR. So we're going to write this in determinant notation. So in the first row, we get I, J, K. In the second row, we're going to get the entries 1, negative 1, 0. In the third row, we get 1, 0, negative 1. Okay? Now, to take this determinant of sorts, right? I'm going to take the entry in the first row, this I, and I'm going to eliminate the row and the column that contains the I and take the determinant of what's left. So in other words, I'm going to take the determinant of negative 1, 0, 0, negative 1, and then multiply that result by I. Okay? When I go to the J, I'm going to eliminate the row and the column that contains the J and take the determinant of what's left. And we're going to change signs. So we're going to go minus the determinant of, and then from here, I write 1, 0, 1, negative 1. And multiply that result by J. Then I'm going to go plus. And then, again, we're expanding around the first row, right? So I look at the entry K and eliminate the row and the column that contains the K and take the determinant of what's left. And what's left is 1, negative 1, 1, 0. So I take that determinant times K. Now, one quick recall. When we take the determinant of a 2 by 2 matrix, A, B, C, D, this is equal to AD minus BC. So we get a number back. And so here, you're going to get 1I minus negative 1J plus 1K. Or we could write this vector. That's one way to form the vector, by the way. Or we can write the vector as 1, 1, 1. And so I chose this second notation when I formed the vector n. I hope that helps. So that'll conclude this video for section 12.5, and we did problems 31 and 35. And I do something similar to find the normal vector for problem 35. So I expand around the first row, and I eliminate the row in the column that contains the I to get the first component, basically. You know, I take the determinant of this 2 by 2 matrix to get the first component. And then I keep going. So, okay, thank you.